Question number 8 says Jolene bought a car which depreciated in value at a rate of 3% per year. At the end of the first year, it is worth $19,400. Which of the following functions represents the relationship between the years since the car was purchased and the value of the car? Key word here, the very first sentence, right here, says the car depreciated in value at a rate of 3% per year. What does that word depreciate mean? Think about that for a second. See if you can recall. Depreciate means the value is going to increase or decrease. What do you think? Hopefully your instinct was to say it decreased. If you didn't know what it meant, maybe just the prefix here, depreciate. Maybe that would help you realize that means it's decreasing. All right. So it is going to be going down in value, which should make sense. You buy a new car, the value is going to go down after you buy it. And it's depreciating at a rate of 3% per year. We've talked about this in class as well. Anytime a function is either increasing or decreasing by a percent every year or every time period, if it is a percentage and not just a regular number every single time, that percent is going to be an indicator that we're dealing with an exponential function, which also should have been obvious because look at all the answer choices. All the answer choices for this particular problem are all exponential functions. They have a starting value, a rate, and then you raise that to an exponent of t. Now, if it says it's depreciating at a rate of 3% per year, think about this. What percent of the original value was your car worth the moment you bought it? Okay, you paid 100% of the original price. Now, if it is decreasing 3% from the original 100% that you paid for it, what is 100% minus 3%? 100% minus 3% is going to give you 97%. Okay? So this is the original percentage of the value. It is going down 3% this year. So now you are at 97% of the value. So whatever it started at, we'll just call that A right now. The original value is going to be multiplied by 97%. Now, we don't ever write percents in our expressions. Okay, that's not what we put in the parentheses. I need to change this from a percent to a decimal number. So, just reminding you of how to change this from a percent to a decimal. To change a percent to a decimal, okay, we're going to drop this symbol, and it is 97%. There's no decimal there, so we put one at the end of the number, and it moves 2 places to the left. So this becomes 0.97, and I'll just put a 0 to kind of have that decimal stand out. So 97% becomes 0.97. This is the number we would multiply by each year to figure out the new value every year. All right, and again, t represents the number of years it's been. So right away, looking at our answer choices, we can cancel out A and C. Those would be if the car was increasing 3% every year, because 100 plus 3 is 103%. Move the decimal 2 places on that, and you would get 1.03. Another giveaway, remember we talked about this. Anytime the number in the parentheses is greater than 1 in an exponential function, it's going to grow. That is exponential growth. Anytime it is less than 1, that is exponential decay, and it's going to decrease, which is what we want. So the answer is either going to be B or D, just based off of that fact. So then we just have to look right here, and I think it's pretty obvious why B is written here, because there's that number, 19,400. Well, where does this 20,000 come from? Well, let's read this more carefully. It says at the end of the first year, the car will be worth $19,400. So if I was to think about this like I was looking at a table, then that would tell me that, okay, if I'm keeping up with the number of years and the value of the car, B of t, since we're using function notation, if I'm concerned with 1 year, we know that the car is going to be worth $19,400. But is that where the car's value started when we originally bought it at 0 years? No, it's not, because that value is going to have been decreased by 97%, or excuse me, decreased by 3% from the original value. So to figure out, think about this, if I wanted to know the next year how much it's going to be worth, I would multiply that, since this is exponential, multiply that by 0.97. Figure out what is 97% of 19,400, and that will give me the next value. and then just keep repeating that pattern to figure out each year how much it's going to cost. So we are multiplying by 0.97 as we go to the right. Now if I want to know how much it cost years before, we just do the opposite of that. So I'm going to turn around and divide by 0.97 to see what I would have had from the year before. So if you take your calculator and you look at the original value, again, give this a second to load up, this particular calculator application I found. It's really neat. You can actually get this for free online if you, I know it's the end of the year now, but next year, if you don't have a personal calculator, just let me know and I can give you the link to this page. It's only good for 90 days unless you buy it, but again, 90 days, that'll give you actually that'll be most of the semester. And since most of you will be in semester-long classes, this could be very useful. And then maybe if it's something you like, it could be something you purchase just for your home computer. We'll see. Anyway, again, back to our problem. Let me clear this out. It said if we knew that 1 year later it was at 19,400, we want to know the year before. We just saw that if we divide that by 0.97, figure out the year before, then that tells me I started with a value of 20,000. So clearly that is going to be our other answer choice, which it had to be. If we knew this was where it was after 1 year, it couldn't have started at that value, so it had to be something bigger. And in fact, we just saw that it is 20,000. So the correct answer is D. V of t equals 20,000 times 0.97 to the t power. That's question 8. Go ahead and work on the next question.